Hello everyone, welcome to this video. This is lecture number 17. In this video, I want to discuss the question number 20 to 29 of chapter 2 of this book, that is Vasudev Ghosh of electricity and magnetism. The previous chapter 1 and the chapter 2 question 1 to 20 question 19 already covered in the previous lecture. You can watch this, link given in the description box. Also, we solved the electrodynamics book by DJ Griffith of chapter 2. Problem already solved. You, if you want, you can watch this video also, link given in the description box, right? So let's start today's question, that is question number 20 of chapter 2 of this book, that says a cavity of radius A is made in a large block of dielectric constant K. This is a dielectric material whose dielectric constant K, and within the dielectric there is a cavity of radius A. If a charge Q is placed at the center of the cavity, there is a charge Q placed at the center of this cavity, so that the electric field at a distance r, which is greater than 2a, that means outside of this cavity, from the center the electric field will be like that. For that we can use the Gauss theorem, that is for dielectric, d dot ds, d is the displacement vector, is the q enclosed. So if you can see there is q, and in the inner wall there is a minus charge induced. For that, in the outer wall there is a plus q charge. So finally you get this q and the d vector equal to this. So the electric field will be d by epsilon. So d by epsilon, if you can put epsilon equals to k into epsilon naught, so finally we get this is the electric field. Clear? Go to the next question, 21, which says consider a large block of dielectric with uniform polarization P. A thin disc shaped cavity is cut into this block. The axis of the cavity bring parallel to P. This is a P and there is a disc. So that the electric field within the cavity due to surface charge on the cavity is given by this. Now, since you can see these within this cavity, the charge due to the volume charge will be 0. That means rho of due to polarization will be 0. But sigma is not equal to 0. There will be induced in the surface in the plus charge and this minus charge in the lower surface, right? So the total displacement vector will be p plus this, and in this region the charge will be 0, d will be 0. So finally we got this electric field will be like within this cavity, within this cavity the displacement vector will be 0, because you know this d dot ds equals to q enclosed. Since this q enclosed is 0, that's why d equals to 0 within this cavity, that is the electric field will be like that. But in case of this, there is be no rho, that is rho of equals to 0, and sigma also 0. That's why there is no electric field within this cavity when this needle will be like that. Clear? When the needle is parallel to this polarization, there is no charge accumulation. That's why no electric field produced in within this cavity. Go to the next one, which says that the thin dielectric rod placed in along x-axis, a thin dielectric rod placed along x-axis, end at x equal to 0 and x equal to L. The rod has uniformly polarized like that. This is the polarized. The find the volume and surface charge density of polarization. So this is a polarization. So volume charge density of polarization, divergence of P. So if you diverge, you will get minus 2ax. Clear? For surface, you can see there is two end for that, because the polarization along this x-axis also. So the charge will be this two end only, no charge in between the no charge in this surface, only these two end there will be charge accumulate, surface charge accumulate. So at x equal to 0, this is p minus I cap, because in this region, the surface direction will be minus I cap, and the direction, the surface direction will be plus I cap. Okay, that's why this is for at x equal to 0, this is p dot n cap is minus I cap, so p dot minus I cap, you will get this, and put the value x equal to 0, you will be get minus b. Whereas at x equal to L, this is n cap is I cap, so put this p value and this I cap, I dot I is 1, and in this value put x equal to L, you will be get this expression. Okay, so there is no volume charge there is volume charge density like that, and the surface charge density only these two end. Within that region there is no surface charge density, right? Go to the next question. A plane slab of dielectric with dielectric constant K is placed in free space. Suppose there exists an electric field E0 in this free space, where E0 is uniform and the perpendicular to the boundary of the slab. Find electric field and polarization P within the slab. From this Gauss theorem, you can find out the displacement vector. From displacement vector, you get the electric field, right? And for polarization, this electric field minus this, you know, this total displacement vector was polarization vector plus epsilon naught E. So from this relation you get the polarization equal to d minus epsilon naught E. Put the value of d is E into epsilon into E, so finally you get epsilon naught taken common, take as a common, so epsilon by epsilon naught is K minus 1 and E is. So if you put the value of E, you will be get this polarization vector. Next question. Consider a dielectric rod of length 2L of radius A. This is a radius A and length 2L, which has uniform polarization P on its axis. So this is a polarization P on this axis. Find the electric field due to this rod at the axis point at the distance x from the center of the rod. So we need to find out the electric field at the point of x from the center at a distance x, right? So from the formula, that volume charge density will be 0 because this pu will be constant, so derivative will be 0. But the surface, in the lower surface you can see there p and this is minus z cap, so there is a minus p surface charge density in this lower surface, that is this is sigma p and this is sigma p in that region. So you will be get this surface charge density in upper side and lower side. Okay, so the electric field at that region, this is like a disc, circular disc, right? So this is like a circular disc with radius a, and this distance will be L minus x because this is 2L, that means from center to that is L, and this is x, so this distance will be L minus x. So if you put this value of this formula, if you remember, for a disc, the electric field at a distance x, this was the x by root under x square plus x square, right? So if you put, and this was the p is the surface charge density, which was there was a sigma. So put this value for this charge density and also for this charge. This is positive for this is outward and this is negative, this is inward. So finally these two are added. So if you add these two expression, you will be get this. I think you remember this expression. This is the electric field for a disc at a on the axis at a distance x. Clear? I think remember this figure like that. Oh, sorry, like that. This is a disc with a distance x, and this was a, so electric field at distance this with sigma. The relation, I think, minus sigma by 2 epsilon naught 1 minus x by root under x square plus s square. This was the relation for this disc. Here these two are like this, the positive charge disc and this is negative charge disc. So finally you got the electric field by adding these two, because these two electric field are in same direction. Go to the next question, which says, so that the electric field E0 within a long narrow needle shaped cavity cut into dielectric is equal to the electric field in dielectric when the length of the cavity along the electric field. This is the electric field within this dielectric and this is the cavity. Here you can see this due to this there is no charge accumulated because of this surface is not permanent and this region is very small, so surface is very small, volume charge density is 0 and surface charge density is 0, so the polarization d equal to like that, and there is no charge within this, so that's why we write e0 epsilon naught e0 within this. There is no material, this is vacuum, that's why epsilon naught e0, and here there is no polarization, this will be 0, so finally you get e0 equals to e in that case. In that case there is a charge separation, will be charge and minus, so say surface charge density is not 0, so you can write this as a segment and p equal to not 0, that's why this is a total d, right? Go to the next question. Suppose an electric field lines moves from medium having a dielectric constant k equal to 6 to second medium 2. That is, the electric field goes from this surface to that surface where k1 equal to 6 and k2 equal to 2. If the electric field lines in the first medium make 60°, this angle is 60° with the normal interface with the angle. Find out the second medium. This we need to find out this angle. For that, you remember these two boundary condition, that is the displacement vector. This was the displacement vector is discontinued by sigma, and the normal component of displacement vector was discontinued by the sigma surface charge density, and the parallel component or the tangential component of the electric field will be continuous, right? So if you put this sigma equals to 0 because there is no charge density, so you will be get this relation, and from this relation you will be get that is E2 perpendicular, that is this is E2, it has two components, the E2 parallel and this is E2 perpendicular, and this is E1, this has also two components, E1 parallel and E1 perpendicular. So for perpendicular we got this relation, that is the relation, that is the E2 perpendicular equal to 3 into E1 perpendicular, whereas in the parallel these two are equal. So if you write down in the theta component, so E1 parallel means this is E1, so this angle is 60, means this angle is 60, so this was E1 sin 60, right? And in case of this also this is 60, so this is the E2 parallel is E2 sin theta, if we take this angle is theta, and from this relation this is E2 cos theta, and this is 3E1 cos 60, this is E1, so this is E1 cos 60. If you divided 1 and 2, and you will be get easily the angle of theta. Clear? I think clear. If there is any doubt, you must comment in the comment box. Go to the next question. 27 says the angle between two OH bond of H2O molecule is like that. So the angle between two OH bond is like that. Assume that each OH bond is associated with the dipole moment is 1.51 diopter. So these two dipole moment value is 1.51 diopter. Calculate the dipole moment of water of a water molecule. So these just like it two these two are vector, so if you added these two vector you will be get the formula, you know, the a square plus b square plus 2ab cos theta. So put the value of dipole, this magnitude will be the same, this magnitude will be same, so you will be get p as a common, you will be get this relation, and this angle will be 108°. Putting this value you will be get this value, right? Go to the next question. So that the field line due to dipole in a plane represented by this relation, where theta is the angle between dipole axis and radial vector. So this is a dipole and this is any position, the angle will be theta, and this distance will be r, the distance is r, right? So the potential due to this dipole is given is here, that is 1 by 4 pi epsilon r p dot e rq, p dot e rq. So this is 1 by 4 pi epsilon r p cos theta by rq. This was rq. This is a mistake. rq, rq. Sorry, r square. This r is cancelled out. R square, right? So the electric field of the r component will be del phi del r. So if you derivative with respect to r, you will be get this equation for theta component, and this is psi component, r theta phi in the spherical polar coordinate system. These two component present, this is 0. And dr vector can be written as in any position vector, position vector derivative written as like that. So if you compare this coefficient r cap and theta cap, and r cap and theta cap, and putting this value you will be get 2 cot theta, and just separate out, you will be integrating, then you will be get this sin square theta by r equals to constant. I think clear. And the this was the potential for equipotential surface. This potential must be constant. So if you put this is a constant, you will be get cos theta by r square equal to constant, which needs to prove here. That also so that the equipotential surface given by cos theta by r square equal to constant. In case of the electric field, the represented by dipole, sin square theta by r equals to constant, sin square theta by r equals to constant, whereas equipotential surface represented by cos theta by r square equal to constant. Go to the next question, which says the potential due to dipole is given here. We just written in the previous question, just written that is a potential. So this is the potential. Using this relation, find out E equal to minus grad phi, find E. So using this relation, you need to find electric field. So electric field is minus grad phi, putting the value of phi. If you take these two, this is a scalar and this is a scalar, so divergence of P dot R 1 by RQ, and this is into RQ. If you wants to find out this expression, is a fourth term, I think you remember this, A dot B equal to A cross curl of B, and so on. So here curl of R is 0, P is a constant, so curl of P is 0. Here also P constant, so this is like derivatives, this is also 0. Only this term exists. P can be written as 3 component, that is Px I cap, P can be taken as Px I cap plus Py j cap plus Pz k cap. If you take this as, so you can write divergence, you remember I cap del del x, so this will Px del del x, Py del del y, and Pz del del z, and this was the r vector I cap x j cap y. So if you derivative when, then you will be get I cap in case, and that when we derivative with respect to y, will be get z cap only, with respect to z will be k cap only. So this is nothing but p vector. So finally we got from this expression we will be get p vector only. And in case of the 1 by rq, this is nothing but the derivative with respect to r and with a r cap. So if we derivative, this is minus 3 by r to the power 4, and r cap is r vector by r. So if you put these two expression in the electric field expression, you will be get finally this expression. And if you take this is a r vector, r into r vector, then this becomes q, which can be taken as a common. Okay, so finally we get the electric field of due to dipole. This is a very important formula, because in the magnetic field you also get the same type of formula in case of the magnetic dipole. This is the electric field due to electric dipole, and that case this was the magnetic field. In case of magnetic dipole, this expression will be the similar. Clear? So this is an important formula, that is the electric field due to a dipole at any position, right? So that's it for today. This is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you will get the others video, and share these videos as that he or she also get benefit. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we will meet in the next video as soon as possible. Thank you.